Okay, hi all. So we are going to continue with market experiments. Okay, so for the market experiments, let me show what is the, okay, here, is it here? Oh, okay, here it is. So we are going to continue with the market experiments. So I'm going to explain this from the chapter 2 of Charles Hall's book. So this is a simple experiment. Okay, so first market experiment is run by Chamberlin by letting students with buyer or seller roles to negotiate trading prices. Okay, the purpose was to illustrate systematic deviations from the standard theory of perfect competition. Okay, so because in a classroom environment, perfect competition assumptions are not going to be held. Let's see how it is the design. Okay, in any market experiment, actually, this should happen. Each seller should be assigned a cost, or each buyer should be assigned a value, because in the real market, there are such things, even though it's not named. If you are selling a house, you value it. You determine the value either by looking at the price of the similar houses or etc. Okay, as a seller, or if you build it by yourself, you decide according to the cost, etc. As a buyer, you value it. Either you determine it according to the location or the number of the rooms, whether it gets sun or sunlight, etc. Okay. So in here in the laboratory, subjects are selling or buying an hypothetical object. Okay, so there is no object in the laboratory, but they are deciding according to these values and costs. Okay, each seller was given a card with a amount or cost written on it. For example, one seller may have a cost of 2, another may have a cost of 8. Okay, we are going to come to an example related to that. This is the reason why I am giving such numbers in here. And seller's earnings will be what? Sale price minus the cost. Okay, as we do in the 201. The low cost seller would be searching for a price above the cost. Its cost is 2, and high cost sellers will be searching for a price above 8. The cost is not incurred unless a sale is made. So the product is made to order. It may change actually, right? So if you grow a vegetable, for instance, this is the condition in the laboratory, but in the real world, you bear the cost if you cannot sell the good, right? So for instance, if you grow a vegetable and then you're going to sell it in the market, then if you cannot sell it, it can perish, right? So it can perish. So if, for instance, if you are producing a milk, you have a cow, you get the milk from the cow. If you cannot sell the milk, it's gonna be spoiled, so you cannot get money from it. Okay, so it's important the seller can get a cost. Okay, actually the goods are separated into two in that respect, the goods that are perishable or not. Okay, because it's gonna affect the bargaining power of the seller, right? So they may be different experimental questions or research questions, actually. If you're interested, you can look at that. The cost is not incurred unless a sale is made. The product is made to order. The seller wouldn't want to sell below cost since the resulting loss is worse than the zero earnings from no sale. Okay, sellers is not going to sell below the cost. And similarly, for the buyers, we are going to give a card to buyers on which value of the good is written. So buyer's earning will be value minus price. A buyer with a value of 10, for example, would earn the difference between price and the value. And similarly, there can be buyers with the low valuation 4. Okay, so in order to avoid negative earnings, we are gonna restrict buyers to pay a price above their valuation. Okay, if they are high value buyers, they cannot buy a good above 10. If they are low value buyers, they cannot buy a good above 4. Okay, the market is composed of a group of buyers and sellers who can negotiate trades with each other either bilaterally or in larger groups. Okay, so if two people are negotiating each other, we are calling it as the bilateral negotiation. Okay, if there are many people and they are bargaining each other, it is multilateral. Okay, so for example, suppose that the market structure is like this. So we have 8 buyers and 8 sellers. 4 of them have low valuation, 4 of them has high valuation among the buyers, and for the sellers, 4 of them have low cost and 4 of them have high cost. Okay, so in addition to the structural elements of the market, number of buyers and sellers and their values and costs, we must consider the nature of the marketplace negotiation. What are the rules? Okay, a market institution is a full specification of the rules of the trade. For example, one might let sellers post catalog prices, then let buyers contact sellers if they wish to purchase at the posted price with discounts not permitted. Okay, this is the rule for the market negotiation. Okay, this institution, known as a posted offer auction, is sometimes used in laboratory studies of retail markets. The asymmetry with one side posting and the other responding is common when there are many people on the responding side and few people on the posting side. Okay, so market institution is gonna change the rules of the game. Okay, so in for instance, we are going to come to that in double auction. Each either buyer or seller can make an offer. Okay, in this situation, in the posted offer case, so one of the sides are making an offer. Okay, so this is making the game as asymmetric. Okay, okay, so Chamberlin used an institution that was symmetric. Okay, both buyers and sellers make an offer. He lets buyers and sellers mix together and negotiate bilaterally or in small groups, much as traders of futures contract interact in a trading pit. Okay, you don't interact with everybody. Okay, you are choosing someone and then you negotiate over the good at a pit. Okay, sometimes he announced transaction prices as they occurred. At other times, Chamberlain didn't announce prices as they occurred, which may have resulted in more decentralized trading negotiations. Okay, participants were students at the University of Virginia Education School who were interested in new approaches to teaching economics at secondary school level. So this was in 1948. Okay, this is the beginning of the experimental economics. Even it was by then there was no beginning. Okay, so when a buyer and seller agreed on a price, they came together to the recording desk, where the price was checked to ensure that it wasn't lower than the seller's cost and not higher than the buyer's value as required by the instruction. If it satisfies, they are going to pay it accordingly. Okay, so according to this figure, okay, so it is this marketing situation run multiple periods. Okay, and in period 1, these dot corresponds to trade, number of trades. Okay, 5 goods are 5 goods are sold. Okay, in the second period, 6 goods are sold. Okay, 6 trades occurred. In 3 and 4, 4 goods are occurred, and these are also showing you the traded prices. Okay, as you can see, in period 1, there is a diverse, a quite high variance in the agreed prices, right? There's a goods sold at 10, 9, 7, 4, 3, okay? But as it moves to the later periods, in period 3 and 4, the prices are either 7, 6, or 5, okay? It came to the interval 5, 7 interval, okay? Consider the question of, so the prices converge to some level. Consider the question of why prices converge to 5, 7 range with the transaction quantity of 4 units per period, okay? So remember, in period 3 and period 4, 4 units are sold only, okay? So actually you can find the equilibrium price and equilibrium quantity with these valuations and with these costs, right? So I showed you in 201. In order to, before running an experiment, you should form your hypothesis, okay? So this theoretical prediction is telling you that how many goods should be sold, what will be the equilibrium price, okay? So before analyzing your data, you should know your prediction, okay? So, okay, so notice that quantity could have been as high as 8, okay? For example, suppose that everybody can trade, okay? How it can happen, and under these conditions, okay, buyers are not gonna buy above their valuation, sellers are not gonna sell below their costs, okay? How can it happen? High value buyers can trade with the high cost sellers, okay? High cost sellers costs are 8, high value buyers valuation were 10, okay? If they trade at a price between 8 and 10, these 4 high cost and high value buyers can trade, and similarly low cost and low value low cost sellers and low value buyers can trade if the price is 3, okay? So remember, the cost was 2 for the low cost sellers, and for low value buyers, value was 4. If the price is between those, they can trade as well. So then 4 units would be sold, 4 units would be sold, traded between high value, high cost traders, and 4 of the items would be traded between low value buyers and low cost sellers. Okay, in this scenario, all of the sellers units sell, the quantity is 8. Each person earnings would be what? 1. Okay, so high value sellers and high value buyers and high cost sellers would earn 1. Everybody would earn 1. Prices, however, quite variable would be the case. This is not the case what we observed in the earlier figure, right? So these patterns are not observed in the sequence of the trades shown in figure 2.1. There's high variability initially, okay, as some of high costs are sold at high prices and some of low value units are purchased at low prices. By the third period, prices have converged to 5-7 range. That prevents high-cost sellers from selling at a profit and low-value buyers from buying at a profit. Okay, so high-cost sellers and low-value buyers couldn't trade. Okay, the result is that only 4 low-cost units are sold to 4 high-value buyers. Should it be the case? Now let's check whether the first scenario could happen. Okay, why do we observe low price dispersion in later periods? Okay, so at a price 9, okay, in the first scenario, if everybody traded, okay, and obtained 1, at a price 9, all 8 sellers, okay, sellers costs were what? 8 or 2, okay? All 8 sellers would be willing to sell, but only 4 high value buyers would be willing to buy, okay? So in that case, there will be a competition among two sellers, right? So because the number of sellers are more than the number of buyers, okay? And then sellers, in that case, sellers may try to lower the prices to get a sale, causing a price decline, okay? 9 cannot be an equilibrium. This is the reason. 9 cannot be an equilibrium price because at price 9, all sellers would be willing to sell, but not all buyers would be willing to buy. Okay. Conversely, suppose that prices began in $3 range, but at these low prices, all of the 8 buyers would be willing to buy because the valuations were what, 4 or 10, okay? But only four of the low-cost sellers would be willing to sell, okay? This gives sellers the power to raise price without losing sales, okay? So finally, consider what happens with prices in the intermediate range, 4 and 8. At a price of 6, for example, each low-cost sellers earn 4, okay? So 6 minus 2 is the earnings of the sellers, and each high-value buyers would earn 4, okay? Then what will be the total welfare? So actually we are looking at the consumer welfare and producer welfare in here, right? So sum of them is gonna give you the total welfare. So 8 people who make trades earn a total of $32. These earnings are much higher if they were to trade according to scenario 1, right? In which everybody was involved into the trade, but all of the sellers and all of the buyers would earn 1. In that case, there were 8 sellers, each would earn 1, and 8 buyers each would earn 1. In total, $16 would be earned, okay, instead of 32, okay. In this example, the effect of reduced price dispersion is to reduce quantity by half, but it doubled the total earnings, okay. So in the initial scenario in which everybody traded, everybody earned $1 and total earnings were 16, and all of the quantities were sold. The quantity traded was 8, okay. In the second scenario, price dispersion was high. In the second scenario, price dispersion was low. Only 4 of the goods were traded, and total earnings from the trade is 32, okay. The reduced price dispersion benefits buyers and sellers as a group since total earnings go up, but the excluded high-cost sellers and low-value buyers are worse off. Okay, they couldn't trade. It's a 0. Nevertheless, economic efficiency has increased by these exclusions. Okay, so what is the efficiency? How do we measure the efficiency? It is the sum of realized incomes divided by maximum aggregate income according to the prediction. Okay, so you need to predict the total welfare from the trade, and this will be in the denominator. In the numerator, you are going to have the realized incomes from the experiment. Okay, so we are measuring the efficiency by this. Okay, one way to measure efficiency of the market is to compare the actual earnings of all participants with the maximum possible earnings. That was what we were doing. It is a simple calculation to verify that 32 is the highest total earnings level that can be achieved by any combination of trades in this market. The efficiency was 100% for the final 2 periods shown in figure 2.1. Okay, in this figure. Okay, in period 3 and period 4, $32 would be earned. Okay, and then since the 4 units traded in each of these periods involved low cost and high values. Okay, if a 5th unit had been traded, as happened in the first period, the aggregate earnings must go down since high cost $8 sellers for the fifth unit exceed the low value for this unit. Okay, then the total earnings will go drop to 28. Then in order to find the efficiency, you are going to divide 28 by 32. Okay, and in that case 87.5 would be the efficiency. The trading of sixth unit in the second period reduced the efficiency even more to 75%. Okay, actually this is what I was telling you. Okay, and this is our prediction, right? So we have high valuation buyers and low valuation buyers. This pink is giving you the demand. If the price is above 10, nobody is willing to buy. If the prices between 4 and 10, 4 of the buyers will be willing to buy. If the price is below 4, all of the buyers will be willing to buy. Okay, similarly, we have a symmetric situation for the supply. If the cost is below, price is below 2, okay, nobody is willing to, no seller is willing to sell. If the price is between 2 and 8, 4 sellers would be willing to sell. And if the price is above 8, all of the sellers would be willing to sell. Okay, then we found the equilibrium quantity, demand and supply intersect at when the quantity is 4. And equilibrium price can be any price between 4 and 8. Okay, as you can see, only high value buyers and low cost sellers would be involved into the trade. Okay, the guys in the right wouldn't be involved into the trade. Okay, and you can calculate the consumer surplus and producer surplus in here. So you're going to calculate the area of this square, right? Okay, no, this is not square, rectangle. 10 minus 2 times 4 is the total welfare. Okay, so okay, so this is 32. Maximum aggregate earnings are gonna be found like this. Okay, 32, and you are gonna calculate the efficiency from there. Realized earnings of buyers and sellers divided by 32. Okay. So Chamberlain's results and Vernon-Smith reaction. So the negotiations in the class experiments discussed above took place in a central area that served as a trading pit, although some people tended to break off in pairs to finalize deals. Okay, so consider yourself trading in the classroom. Okay, if you find your trading partner, you finish up the trading in private with her or him. Okay, good market information about the going prices will tend to reduce price dispersion. So remember, Chamberlain was writing some of the realized prices to board, some he didn't. Okay, so if he didn't, nobody is aware of the prices realized. Okay, a high dispersion is needed for high cost sellers and low value buyers to be able to find trading partners. So less dispersion will tend to exclude these extra marginal traders. Okay, so if they are included, quantity traded will be higher and the price dispersion will be higher. It's going to deviate from the equilibrium prediction, right? As the information is more decentralized. Okay, Chamberlain did report some tendency for the markets to yield too many trades relative to competitive predictions, which he attributed to the dispersion that can result from small group negotiations. Okay, in order to evaluate this conjecture, he took the value and cost cards from his experiment and used them to simulate a decentralized trading process. Okay, so he used the simulation. Okay, this is not the experiment. These simulations were not laboratory experiments with student traders, They were mechanical, the way one would do computer simulations today. Okay, the simulation analysis suggests that market efficiency will be higher when price information is centralized, so that all traders know the going level of bids, ask, and transaction prices. Vernon Smith, who attended some of the Chamberlain's experiments when he was a student at Harvard, used this intuition to design a trading institution that promoted efficiency. Okay, and he got the Nobel with that. Okay. After some classroom experiments of his own, he began using a double auction in which buyers made bids, sellers made offers, and all could see the highest outstanding bid and the lowest outstanding ask. Okay, buyers could raise the current best bid at any time, and sellers could undercut the current best ask at any time. Okay, sellers' offers are named as ask, buyers' offers are named as bid. Okay, in this manner, the bid-ask spread would typically diminish until a seller accepted a buyer's bid or a buyer accepted a seller's ask. Okay, this is called a double auction since it involves both buyers and sellers. Yeah, this is the reason why we have double auction. A trade occurs when these processes meet, when a buyer accepts a seller's ask or when a seller accepts a buyer's bid. Okay, this is the double auction description. Actually, they saw such a screen on their. This is a screenshot. We did an experiment in here like a couple of years ago. Okay. Okay, they know their roles at the top. Okay, if you are a seller, you are seller during the whole experiment. If you are a buyer, you are buyer during the whole experiment. And on the left, you see the value. If you are a seller, you see the cost of your good. If you are a buyer, you see the value of your good. Okay, and you are given information about your profit function. Okay, so if you are a seller, price, so you will be paid price of the good minus the cost of the good. If you are a buyer, you are going to be paid value of the good minus price of the good. Okay, so in here on the top, alış teklifleri, which is written as alış teklifleri. Okay, you see the offers of the buyers. Okay, or you see offers of the buyers. Okay, if you like one of the offers in here, you can click on it and say sell. You are seller, remember? Okay, and you also see the offers of other sellers on the right. On the right, satıcıların teklifleri part. Okay, and then you can also make an offer by yourself by writing down a fiat here, and you can click on the teklif yap button. Okay, and then in the last square, you are seeing how many buyers are left in the market and how many sellers are left in the market. You also see the trading and you also see the prices. Okay, so this is pretty centralized. Okay, compare it with the Chamberlain's design. Okay, in the classroom, you don't know who agreed at what price. You don't know all the offers. Okay, and this is also multilateral. Okay, yeah, everybody is trading with each other. Everybody solves the offer. Everybody sees the bids, etc. Okay, so this is called as multilateral bargaining, and if you are bargaining with two person, it is bilateral bargaining. Okay, so an 8 trader example. So this is a price negotiation sequence. Okay, buyer to actually in here we do not give any information about who gave these offers, but as you can see, the sellers offers are increasing. Okay, so you cannot give any offer below that, right? Because you know that the others offer, these offers are not accepted. Okay, similarly for the buyers. Okay, this is the reason, like this undercutting, overcutting thing. Okay, so for instance, buyer 2 gave a bid of $3, and similarly seller gave a ask at $8. Buyer 1 gave $4, which is higher than the buyer 2's bid. Okay, and seller 6 gave an ask, gave a price offer which is lower than 8. Okay, and then seller 7 gave 6, which is lower than seller 6 offer, and buyer 2 accept at 6. Okay, so in a double auction, it means that, so you can see in here, right? Buyers increase the prices, sellers decrease the prices, and they agreed at some point. Okay, and all of the offers, since all of the offers are seen, they converge to each other. Okay, but if you take seller 5 and buyer 1 went to a place, they do not they do not see the others offers, etc. This price can be higher than what happened in here, right? Okay, this is like why we have for instance kuyumcuların hepsi niye bir arada, değil mi? Mesela, so for instance, you are gonna buy a gold. Okay, actually it happened to me earlier. Okay, if I buy a gold from a kuyumcu, which is separate from the others, okay, he can sell me at a high price. Okay, but if all of the kuyumcus are at the same place, the price will be like the competitive in here, because if you don't like one seller's price, you can go out of the shop and buy from someone else. Okay. Yeah, her yer, in everywhere you can see that actually. Okay. Okay. In a double auction, there is always a good public information about the bid-ask spread and about past contract prices. This information creates a large group setting that tends to diminish price variability and increase efficiency. Okay. Yes. Summit reported that this double auction resulted in efficiency measures of over 90%, even with relatively small number of traders and with no information about others' values and costs. Okay, so the double auction tends to be somewhat more centralized than a pit market, which doesn't close off the possibility of bilateral negotiations that are not observed by others. Okay, double auction trading more closely resembles trading for securities on the New York Stock Exchange. Okay. Besides introducing a centralized posting of all bids and ask and trading prices, Smith introduced a second key feature into his early market experiments: the reputation of the trading in a successive market periods or trading days. Okay, the effects of reputation are apparent in the figure 2.4, which was done by the Econ web-based interface in a classroom setting. Okay, so you can see in here on the left part, you see the equilibrium price and quantity. Actually, there are many different buyers with different valuations and different many sellers with different costs. Okay, and there's a shock came to the market, both demand and supply shift. Okay, and then even with the shift, okay, shift occurred at period 3. Okay, and these dots are on the right are the realized trades. Okay, realized trades. As you can see, it all converged to the equilibrium price. By period 2, converged to the equilibrium price. Similarly in here, okay, convergence is quite fast, even with that many differences in the valuations and costs. Okay, we have discussed several alternative market institutions in here. Chamberlain's pit market corresponds to most closely trading of futures contract in a trading pit, whereas Smith's double auction is more like the trading of securities on the New York Stock Exchange. A posted offer auction, where sellers set prices on a take it or leave it basis, is more like a retail market with many buyers and few sellers. Okay, so these different trading institutions have different properties and applications. Okay, and outcomes need not match competitive predictions. Okay, so in double auction environment resembles satisfy the equilibrium prediction most of the time. Okay, so what were the assumptions of perfect computations? So we were assuming that agents are rational and selfish, or utility or profit maximizers. We were assuming that a homogeneous, well-defined good is traded. There are numerous firms and consumers, and agents are price takers. Okay, price is determined at the market. Okay. In Smith experiment, with remarkably little learning and strict privacy about valuations and costs, with the modest number of traders and inexperienced traders, we observed a convergence rapidly to a competitive equilibrium under double auction institution mechanism. Okay, the market works under much weaker conditions than traditionally had been taught, and there is no need for large number of traders, no need for perfect information about supply and demand, and you don't need price taking behavior. Everyone in double auction is a price maker as much as price taker, right? You can make your own offers, or you can accept one of the offers made by others. Okay, so what are the difference between Chamberlain's and Smith's experiments? Their designs are replicated by many experiments. The results of the experimental methodology derive the results, right? So both of them are doing the same. They are asking the same question, whether we observe the equilibrium prediction, equilibrium price and equilibrium quantity in a market environment. But Chamberlain couldn't find that, okay? But Smith did, okay? So in Chamberlain, the predictions of the model are not realized. Smith, very clear tendency for predictions of the model, and convergence is fast, he said. Details are very important in the experimental design. One must repeat and replicate the experiment in order to test its robustness to variations, okay? So for instance, do the results of Chamberlain depend on specific features of the experiment? To address this, one must replicate the experiment until she or he doesn't get the same results. Smith first changed supply and demand, nothing changed. He changed the participants. Instead of students, he used other people, nothing changed. But if the rules of the market have been changed, yeah, it changed the results, okay? So instead of like having a bilateral trade, having the multilateral trade bring the results. Okay, thank you. Let me know if you have any question. Allah, ne oldu?